Hello, my name is John Jino Kim and I'm an instructor at Elite Educational Institute. For this session, we'll be going over two problems in AP Calculus AB and BC. So let's start with the problem number one. Find limit as x approaches 0 from the right of 1 over x to the power of x if it exists. For this problem is a simple application of L'Hopital's formula. So now if we take a look at 1 over x to the power of x as x approaches 0 from the right, you notice that our base 1 over x goes to what? Infinity as x approaches 0 from the right. While my power x goes to what? 0 as x approaches 0 from the right for obvious reason. Therefore, we have a case of infinity to the power of 0. Now, this case can get a little more complicated because depending on which one goes to infinity, whether the base goes to infinity faster or the power goes to 0 faster, our answer can change. So, to determine what my actual answer is for this case, we're going to try set this our expression equal to y, and what we're going to do is we're going to take the ln of it. And then we're going to find the limit of this ln of y as x approaches 0 from the right. Reason why we do that is because if we can find this, then this thing is same thing as ln of limit as x approaches 0 from the right of our expression at hand. Which means as soon as we do about it, we can figure out this here by what? Taking the whole thing to the power of e, and that would give us the answer. Okay? So let's start by focusing on finding our answer to this thing. Okay? So limit as x approaches 0 from the right of ln of y, where y is 1 over x to the power of x. Now, ln of 1 over x to the power of x is, we can take our power x outside my ln expression, which gives us ln x times ln of 1 over x, and 1 over x can be translated as negative x ln of x. So what this means is this is going to be equal to limit as x approaches 0 from the right of negative x times ln of x. Now, it looks like this doesn't really help us with the limit, with the L'Hopital's rule. However, there's one thing we can do about it, because you see x approaches what? 0, this part goes to 0, while ln of x as x approaches 0 from the right goes to negative infinity. Now, what we can do here, so it doesn't look like we can utilize L'Hopital's formula, which dictates that it has to go be 0 over 0 or infinity over infinity, but we can match that. How? By taking this x and turning it into 1 over x. Now, let's take a look at what happens. We have negative ln of x, which goes to positive infinity as x approaches 0 from the right, and 1 over x also approaches what? Positive infinity as x approaches 0 from the right, as my denominator here goes to 0. Okay? So therefore, it's infinity over infinity, and we are okay to utilize L'Hopital's rule. Okay? So therefore, what do? We take the derivative of both the numerator and denominator, which gives us negative ln of x. We take the derivative of it, is negative 1 over x, and 1 over x, we take the derivative of it, it becomes negative 1 over x squared, which gives us ln of x approaches 0 plus, and we multiply both sides by x squared, and what do we get? And minus becomes plus. We get x, and as x approaches 0 from the right, x is equal to 0. And what do we know? We know by this means if we want to figure out ln of limit of x approaches 0 plus of y, and if we know this is true, then what do we know? We know this is equal to 0. That means this inside expression, the limit of x approaches 0 plus 0 from the right of y, the original 1 over x to the power of x, has to be equal to what? We take the power of e on both sides, and that tells us that limit as x approaches 0 from the right of y has to be equal to 1. Therefore, our answer is 1. Okay? So, this is a simple application of L'Hopital's rule, where you simply realize that for infinity to the power of 0, you know how to turn it into what? Infinity over infinity or 0 over 0 by taking the ln, and then turn it into the form that has infinity over infinity, and then use the L'Hopital's rule get your limit, and then take that to the power of e, and there we go. Okay, it gives us the answer of 1. So it is important that you know the appropriate formula, when to utilize it, how you utilize it, and then do the correct computation. Okay. All right. So let's move on to question number 2. An object starts at point 1, 3 and moves along the parabola y equals x squared plus 2 for t between 0 and 2 with the horizontal component of its velocity given by dx dt is equal to 4 over t squared plus 4. Find the distance the object traveled during this interval. So there are two. So if we take a look at this, we are really moving along the line y equals x squared plus 2 and the derivative of x is given with respect to t, so we're dealing with parametric equation. Okay. So now if we think about this, let's go through with this thing. So let's try drawing y equals x squared plus 2. So we know that it has to be what? A parabola, and we know it starts at 1, 3. And let's take a look at my derivative dx dt is equal to 4 over t squared plus 4. For t, right? T positive, for t between 0 and 2, what can you tell me about this dx dt? This has to always be positive for t between 0 and 2. What does that tell me? That tells me that starting at point 1, 3, my x can only move in one direction. That is to say, we know wherever it ends up, it has to only go through the one direction. Now, why is this important? Because this helps us see that it's moving from one to another. So instead of utilizing our formula as t1, t2, right? The formula for what? Distance object travel, the length of the arc length is going to be square root of dx dt squared plus dy dt squared dt. Now, this thing we can definitely come up with. However, notice that comes a lot harder to utilize. Because why? Because you see, we know dx dt squared 4 over t squared plus 4, but if we take a look at dy dt, what is it? dy dt is equal to 2x times dx dt. And let's think about it. This x here is going to be the major problem because that means we need to solve for x, okay? So let's think about it. So this is one way to do about it. However, if we think about this distance to object traveled, there's another way we can express this. Because we know it goes from one way, from 1, 3 to some other one point there, which we will call x1 and y1. What do we know? There's another way in which we can express this distance. As x goes from 1 to x1, square root of 1 plus dy dx squared dx. Okay? So all we really need to do is figure out this x1 is. And what is this x1? x1 is the value of x when t is equal to 2. Okay? So in order to figure this out, what do we need to do? We need to solve for x with respect to t and then plug in t equals 2. Okay? Thankfully, we have what? dx dt is equal to 4 over t squared plus 4. And at t equals 0, we start at 1, so we know x0 has to be equal to 1. So we're given an initial condition and we're given a differential equation. So it is entirely possible that we may be able to integrate and figure out the exact formula for x. Okay? So let's proceed onwards. dx dt is equal to 4 over t squared plus 4. If we integrate with respect to t, what do we get? X has to be equal to integral of 4 over t squared plus 4 dt. And let's try integrating. So what do we do when we divide both sides, both the numerator and denominator by 4? We get 1 over t squared over 4 plus 1 dt. And t squared over 4 can be expressed as integral of 1 over t over 2 squared plus 1 dt. Now, there is one formula that we're aware of that's given, that's you're expected to know in integrals. It is integral of 1 over u squared plus 1 du has to be equal to arc tangent u. So what does that mean? That means let's use u substitution. If we let u equals t over 2, that means du is equal to 1 over 2 dt. And utilizing the u substitution, what does that tell us? That tells us that this here has to be equal to integral of 1 over u squared plus 1 du. And we multiply 2 to it. Because in order to make this replace dt with du, we send 1 over 2 to the other side, which makes it 2 du. Okay? And we can always take out the constant outside of the integral. So that tells us that this means 2 times arctangent of u, where u was equal to t over 2. So it's going to be 2 times arctangent t over 2 plus c. Now, let's think about something. We know my x is equal to 1 when t is equal to 0. That means x has to be equal to 1, which is equal to 2 times arctangent of 0 over 2, which is 0 plus c. And what is arctangent of 0? 0. Therefore, c has to be equal to 1. Hence, we know x is equal to arctangent of t over 2 plus 1. Wonderful. So, now, what does that tell me? That means x of 2, we plug in t equals 2, is equal to 2 times arctangent of 2 over 2 plus 1, which is to say 2 times arctangent of 1 plus 1. And what do we know about arctangent of 1? It has to be pi over 4. So therefore, we know 2 times pi over 4 plus 1 is equal to pi over 2 plus 1. Hence, that is my x1 here. So I know the distance object traveled during this interval is the length of this blue line, the arc length, which can be expressed as the integral as x goes from 1 to pi over 2 plus 1 of square root of 1 plus, what is dy dx? dy dx is really easy because all we need to do is take the derivative of y equals x squared plus 2 with respect to x, which gives us 2x. dy dx is equal to 2x. So it's 2x squared, which gives dx, which gives us as integral from 1 to pi over 2 plus 1, square root of 1 plus 4x squared dx. And this is what we can punch into a calculator. And that gives us about 5.84. Okay? So, here, we have a two formula, but in many of these questions, it's important to know which one is useful. You see, we could have started off with dx dt with t1 being 0 and t2 being 2, and then start from there. But you see here, it makes things a lot more complicated because not only do you have to deal with 4 over t squared plus 4, you also have to deal with what? Square root of, and then this 2x here with this being a squared here with the 1 plus 4x squared times square root of 1 squared plus 4x squared times 4 over t squared plus 4. Yeah, real pain to punch that into calculator along with all this. It's a lot easier and simpler when we solve for, what is it? X, because you will have to do it with this way anyway, and then figure out what x has to be when t is equal to 2, and then have square root of 1 plus 2x squared, because it's really simple to calculate dy dx, and then punch it in the calculator. This is so many of these questions, sometimes you have two different formulas. It's important to figure out which one is more useful or makes things simpler, and then when you need to solve other formulas, it's important that you know all these integrals that you are expected to know. For example, this was what? Inverse trigonometry 1 with the integral. And then you need to know how to solve differential equation given an initial condition, and then plug in the correct values to get, and then finally utilizing the calculator to get the right value. Okay? So make sure you know how to do that. All right? Thank you.